Hey, y'all, how's it going? My name is Jack Shang, and today I'm trying to explain to you how we determine linear regression and the different models of linear regression, and how we use the linear regression to explain the response variable and its relationship with the other variables that we create. So, just starting off a little bit, our response variable is weight, and we're trying to determine the relation with weight among our other data points and data sets: age, ring, credits, miles, exercise, footwear, intelligence, minutes to class, studies, piercings, tattoos, height. So, just starting off, we have to understand that these variables have to first pass the normality assumption, which you see over here. So all of them pass except for height. And then we take that data and we did a correlation matrix as well to see the strength of the relationships with these variables and the response variable. So we see that ring is the strongest, height being the second strongest, what age being the third strongest, piercings being the fourth strongest, and footwear being the fifth strongest. Keep in mind that the negative also indicates strength. We then ran a simple linear regression with these five variables testing, and we eventually came to find that the ring is the best variable to use, and we ran a simple linear regression using ring, and we found that it was a strong model. The model is good, is a good fit, and the p-value is less than 0.05. And this model teaches us how ring and the values of ring creates a model to basically find out what a person weighs. So you can see that the probability plot is a good normal S distribution. The ring line fit is linear, and it's pretty close sort of to the predicted weight. And then we ran a MLR to use multiple different data variables to figure out how each of them affects each other. And so we start off by eliminating different variables. We took out piercings because the very large p-value, as well as the coefficient. So you have to realize that the coefficient has to be in relation to the correlation matrix. So the signs have to be the exact same. So if this coefficient is positive, over here it has to be positive as well, but you can see that it's negative over here. So that's why we removed piercings. We removed footwear. We removed height female because of the correlation, and we removed height male because the coefficient is negative and the correlation matrix is positive. And eventually we came to two variables, age and ring, and both of these coefficients match. The p-values are less than 0.05, excuse me. And if you look over here, it's S-shaped. The fit is relatively acceptable to the predicted weight. Our CLR, we processed it through SPSS, and our team member didn't create graphs for it, but basically you can see that the different excluded variables that we took out, and we ended up having just age and ring again. So in conclusion, but for the CLR, we also created different external variables. So they're combined variables that we use to create new categories and see if it would be a stronger relation. And to summarize it, basically we found that the CLR had the best fit for the weight, as in the coefficients and the intercept, even with the error, best fit the weight class if you input certain variables. So let's say, like, for age, the person's 35 years old and the ring size is 14. For this model, it would plus 1.88 for the intercept. It would hopefully come out to equal a certain number on the weight scale. But with the CLR, it helped us define and predict the weight the strongest. So that's why we chose CLR. All right, thank you for your time.